All right, let's go ahead and solve homework exercise number 11 from section 3.6. We've got, there is frost on the pumpkin, so I'll say that's P, or it is still summer, which is Q. So our original statement is P or Q. We want the negation. So negating this whole statement, applying to Morgan's laws, we're going to, what happens is we apply to Morgan's laws, so we negate the P part, which will be negation of P. The disjunction becomes a conjunction, and then we negate Q individually. So then negate P is there is not frost on pumpkin, and then we change it to a conjunction and it is still, and it is probably negate here, not still summer, okay? So we negated both and changed the or to and. So there is not frost on the pumpkin, right here, then change, whoops, change or to and, right? Oops. So then change or to and, so there's not frost on the pumpkin. All right, wait a minute now to change parts, right? There is not frost on the pumpkin, and it is not summer, okay? So there's our negation, not P and not Q. There's the not P, there's the word and not Q, it is not summer. So choice B is definitely the correct answer. All right, very good. Number 12, select the negation of she is not happy and I am not happy. So again, if you want to make she is not happy is not P, and I am happy is Q, right? So I'm saying the original is negation of P because there's a not there. All right, so then negate this. So applying to Morgan's laws, and the negation of P is just P. The original is and, not P and Q, right? Not P and Q, so we're going to do the negation of P, which is P. The and becomes or, and then we negate Q. So in English words, P is she is happy, right? We get rid of negation. Or, right? The and becomes or, and the negation of Q is negation of Q. I am happy is I am not happy. Okay? So we negated P, she is not happy, so she is happy, or I am not happy, right? Negation of I am happy is I am not happy, and the conjunction became a disjunction, so choice C is definitely the correct answer. She is happy is negating P, the and becomes or, and negation of Q is I'm happy is I am not happy. Okay, so choice C would definitely be the correct answer. All right, number 13, the negation of the following statement. Okay, we have negation of R or negation of P. There's the statement. And then we negate the entire statement. So now applying to Morgan's laws, the negation of R is just R. The or becomes and negation of P is just P. So then it would be R and P, negating both, so they would just become R, P, and then the or becomes an and. So it would be R and P would be the negation applying to Morgan's laws. So again, it would be R and P. Number 14, determine if any of the three given statements are equivalent. You may use information about the conditional statement, inverse, contrapositive, De Morgan's laws, or truth tables. So the first one is A, if she exercises, so we'll say that's P. If P, then she does not gain weight, which will make it not Q, right? So that's A. And then B would be she does not exercise, which is not P, or she gains weight, which is Q. And then the third one in symbols would be if she does not exercise, which is not P, then she gains weight, which is Q. Okay, now we have the choice. All right, now let's look at these. For choice A, if P then not Q, okay, we know it is logically equivalent to the contrapositive, which is you negate both and switch the order. So it's logically equivalent, negate both, so then negation of Q would be Q, right? You switch the order, then negation of P, okay? Now, okay, what we have here is, notice, this is negation of P, then Q. These two are converses, right? You switch the order. The converse is not logically equivalent, so we know that A and C are definitely not equivalent. So A and C are not equivalent, okay? Now we've got to go ahead and check B. B is negation of P or Q. So what we can do here is to do this, we're going to go ahead and do a truth table, okay? So we'll do the truth table, and we'll say, so we'll do P and not Q. So we'll go ahead and do P and Q, and we'll go ahead and do, now we're going to do A and B, right? So we're going to go ahead and do P is true, true, false, false. Q is true, false, true, false, right? Now, we're going to go ahead and do if P, then not Q. So we're going to do not Q. Okay, we'll do that. So it's false, true, false, true. Okay, now we'll do if P, then not Q. So we'll do statement A. So if P, then not Q. If true, then false is actually a false statement, right? That's the only time when an if then is true. If true, then true is true. If false, then false. The if part is automatically, if it's false, it's the if then is true. And again, if P is false, then it's true. So the truth table for if P, then not Q is false, true, true, true. Now we got to do the truth table for not P or Q. So we'll do not P. So not P is false, false, true, true. Now we can do not P or Q. So not P or Q, we're doing an or statement with not P and Q. So column 2 and column 5. So true or false is a true statement. False or true is a true statement. True or true is a, I'm sorry, we're doing not P. So true or true, or not P or true, not P or true is a false or false is actually a false statement. Yeah, there it is, line there. Okay, and then not P, true or true is true, and then true or false is true. Now notice, this P, if P then not Q, does not match not P or Q, so these are not logically equivalent. So A is not logically equivalent to C, B is not logically equivalent to, and A is not logically equivalent to B. So then we'll go ahead and do finally the last one, which is we'll have to check if C is logically equivalent to B. So this time we'll go ahead and we'll erase this. Okay. And we'll do by a truth table the not P or Q, and the last statement was what? If she does not exercise, which is not P, then she gains weight, which is Q. So now we'll do these two and see if they're logically equivalent. So we'll do not P, then Q. If she does not exercise, then she gains weight. So not P is false, false, true, true. So now we're ready to do if not P, then Q. So if not P, if false, then true is true. If false, then false is true again. If true, then true is true. And if true, then false is false. So the truth table is going to be true, true, false. And then the negation of P or Q is again negation of P or Q. Not P or Q is true. Not P or Q is false. And then not P or Q is true here. And not P or Q is true because at least one's true. Again, these do not match. So B and C are not logically equivalent. So finally, the answer is none of the statements are equivalent. So unfortunately, we had to do truth tables, which made it kind of long, but at least we finally got our answer that none of them are logically equivalent. All right, very good. We're going to go ahead and stop this session here. This is your math teacher, Dr. Swears. I hope you found these videos helpful. If you still have more questions, send me an email through the inbox, through the Canvas course. Again, thank you for watching these videos.